Imagine you want to connect two computers so they can share files. You just run a single cable between them. It's easy. But now, imagine you have 30 computers in an office, and every single one of them needs to talk to all the others. Very quickly, you end up with an expensive, tangled mess of wires that is impossible to manage. To solve this physical mess, the earliest network designers created a simple piece of hardware called a network hub. This diagram shows a centralized, star-shaped layout. Instead of weaving cables between every single machine, you place the hub right in the middle and run one single cable from each computer straight into that central box. This approach turned a chaotic web of wires into an organized system. If you bought a new computer, you didn't have to rewire the whole office. You just plugged it into the center, making networks much easier to build and expand. A hub is a very simple device because it only deals with raw electrical signals. It doesn't understand file names or web addresses. It doesn't even know what data it's holding. Because it can't read the information, it acts exactly like a loudspeaker in a crowded room. When one computer sends a message into the hub immediately duplicates those electrical pulses and shouts them out to every other plugged-in computer at the exact same time. Every single machine on the network hears the message. The one computer the message was actually meant for recognizes its own data and processes it, while everyone else on the line simply ignores the noise. This brute force method of copying and shouting signals made hubs very cheap to produce. But as you add more computers to that room, this constant shouting starts to create some serious problems. This circle represents a shared shouting zone. Every computer uses the exact same communication path. In this shared space, if two computers talk at the exact same fraction of a second, their signals physically crash into each other. This creates a data collision. When a crash happens, the network essentially stops. The computers realize the messages were ruined, so they each go silent and wait for a random amount of time before trying to send their data again. The more computers you plug into a hub, the more often these crashes happen. Eventually, the machines spend more time waiting in silence for the road to clear than they do actually sharing data. Another major bottleneck is how a hub handles its total capacity. Instead of giving every computer full speed, the hub's total power is splintered between every active device. If 5 people try to download files at once, they all have to share the same single pool of speed. Each person only gets a tiny fraction of the connection, turning a fast network into a frustratingly slow trickle. There's also a security risk. Because the hub shouts every message to every single port, any computer plugged in can easily eavesdrop on the private data meant for someone else. Ultimately, hubs are just too noisy for modern life. As a network grows, a hub makes it slower, more prone to traffic jams, and much less private. This is a network switch. It looks almost identical to a hub on the outside, but it was designed specifically to fix that shouting problem. As we see in this comparison, a switch doesn't act like a loudspeaker. It acts exactly like a smart mailroom. It recognizes a permanent hardware name tag built into every computer and routes the message down only the specific wire where the recipient is waiting. By targeting the delivery, the switch gives every single computer its own private lane. This allows everyone to send and receive data at the same time without their signals crashing. Switches turned the congested, one-way party line of the hub into a high-speed, multi-lane highway where data flows smoothly and privately. You won't find many hubs in offices today. They are mostly used by engineers who want to use that shouting floor to capture and study all traffic on a test network. But seeing how a hub fails is the best way to understand how networks actually work. Seeing data crash in a shared shouting zone makes it clear why our modern, targeted systems are so incredibly necessary. In the end, the humble hub showed us that the first step to building a giant network was simply finding a way to bring all those messy individual wires together into one manageable center.